So, after understanding this figure, we can write equation for property. B is some property. It may be momentum, it may be some energy, it may be the density, it could be anything. So, B system at time t is equal to B control volume at time t, right. Now, V system at time t plus delta t is equal to V control volume at time t plus delta t minus B1 at time d plus delta t plus B2 at time t plus delta t. So, keeping the previous figure in mind, we can write the any property for control volume and for system, right. Now, subtracting the equation 1 from the second and divide it by delta t. So, if we divide it by delta t, then we will have V system t plus delta t minus B system t divided by delta t is equal to V CV t plus delta t minus V CV t divided by delta t minus V1 t plus delta t divided by delta t minus term, then this is plus. So, plus B2 t plus delta t divided by delta t. Now, as delta t tends to 0, then we can write the equation in a derivative differential format. This will become dB over dt of system. So, this is the rate of change of property of the system is equal to dV Cv. This portion may be written as dV Cv divided by dt, means rate of change of the property in control volume minus B in, what property is going inside the control volume, plus B out, that property going outside the control volume. So, with the help of this equation, which is very famous Reynolds transport theorem, which is also known as RTT theorem, Reynolds transport theorem, RTT in simple form it is written as RTT. So, RTT relates system property. B is any system property, it may be momentum, it may be any other property. So, rate of change of property is equal to rate of change of property in control volume minus B in plus B out, right. So, suppose we want to write the Newton's second law for a given problem, then we know that rate of change of momentum is equal to force for system, and for control volume it will be rate of change of momentum, and that momentum is equal to rate of change of momentum of control volume minus momentum going inside the control volume plus momentum going outside the control volume. So, if flow is a steady flow, then for a control volume which term will be 0? This term will be 0 for a control volume where flow is a steady flow, this term will become 0, but this term is present and this term is also present. So, with the help of this we will have a momentum exchange, and because of the momentum exchange we will have a force. So, let me summarize here what is RTT, Reynolds transport theorem. Reynolds transport theorem is a equation which relates system property to the control volume property, because Newton's second law is applied to the system. So, there is need to develop the system property to the control volume property, because sometime we instead of having a control system we have a control volume. So, for control volume this system property is equal to this control volume property. Now, in case of the Newton's second law of motion, this force is equal to this thing, is equal to rate of change of control, rate of change of property of system. Now, this system is equal to this control volume. So, with the help of these three terms we can write force is equal to this thing also for control volume.